welcome to Virtual Protocol Podcast.
Imagine a digital trading floor, right? But the algorithms aren't just, mechanically executing trades based on some rigid formula.
Yeah, they're actually sitting around in a virtual room.
Exactly. They analyze market signals and literally argue with each other over strategy before risking a single dollar. I mean, that isn't a pitch for a sci-fi movie. That is an actual open source GitHub repository that dropped recently.
It sounds totally abstract, but it represents a massive shift. We're looking at a landscape where the pace of open source development isn't just fast anymore.
Right, it's exponential.
Yeah, exactly. It's exponential. And if you're trying to track this stuff, you can so easily get lost in the noise and just miss the fundamental changes in how software actually operates now.
And that is exactly the problem we are tackling today. So if you have ever opened up your laptop, logged into GitHub, and felt like you were instantly drowning in a flood of thousands of new repositories, all claiming to revolutionize your workflow, obviously consider this deep dive your personal lifeline. We are pulling from a really dense update from the ManuAGI AutoGPT tutorials channel. They highlighted 20 top trending open source projects, but our mission today isn't to just read you a list.
Right. Nobody wants just a list.
Oh, no, we are going to decode why these tools actually matter to you.
Because when you look closely at these 20 distinct projects, a very clear map starts to emerge. We're basically going to extract the signal from that noise.
So spotting the hidden patterns, yeah.
Exactly. Spotting the patterns across these tools to give you a clear bird's-eye view of where technology is actually heading. From that arguing AI trading bot we mentioned, right down to the literal hardware cables plugging into the servers.
Okay, let's unpack this map. We have to start at the absolute cutting edge, I think,
Right.
which is this shift from AI as a generic chatbot to AI as a specialized autonomous worker.
Yeah, the days of just typing a question into a browser window and waiting for a paragraph of text, those seem to be ending.
Thank goodness.
Right. That is the crucial pivot. We are moving from AI that chats to AI that acts. And the foundational tool the source has highlighted to demonstrate this is called the Hermes agent.
Okay, Hermes. That's by No Use Research, right?
Yeah, developed by Noose Research. Rather than just answering a prompt, Hermes is a framework that gives an AI memory, access to APIs, and, the ability to operate files on a system.
So it's not just generating text, it's actually executing multi-step workflows.
Exactly. It operates on an iterative reasoning loop. So it looks at a task, plans a sequence of actions, interacts with an external tool.
And then it checks its work.
Yeah, it looks at the result of that action and then decides what to do next based on that. It is literally an engine for autonomy.
Wow.
But the broader trend the sources point to is what happens when you take that autonomy and hyper-specialize it. For instance, they highlighted a project called Scientific Agent Skill.
Okay, wait, let me push back on that one for a second. Science is entirely based on rigid methodology and reproducible facts, right? And large language models are famously generative. I mean, they predict the next most likely word. They guess. So isn't combining a guessing machine with rigorous scientific research just a recipe for a complete disaster?
Well, it would be if this were just a standard chatbot. But Scientific Agent Skills isn't a standalone application. It is a modular capability layer.
A capability layer. What does that mean in practice?
Think of it as a plug-in brain. It provides structured, highly constrained prompts and domain-specific actions specifically designed for scientific analysis.
Oh, I see.
Yeah, it forces the underlying AI to adhere to a standardized scientific workflow rather than just generating a plausible-sounding hypothesis.
So instead of asking a generalist AI to figure out how to handle your lab data, you are loading up an agent that already knows the exact methodology.
You're swapping out a Swiss Army knife for a highly trained specialist.
Yeah.
And we see this exact same specialization happening in the legal field, too, with another tool they mentioned.
Claude for legal, right?
Yeah.
By Anthropic.
Yeah.
I noticed a very specific detail in the notes for Claude for legal. It's a collection of workflows for document review and drafting, but the source explicitly noted that it is designed to keep humans involved in review.
Yeah, it fully acknowledges the liability there. I mean, in legal operations, an AI hallucination isn't just an inconvenience.
It's a massive lawsuit.
Exactly.
Right. So if you picture this in practice, the AI might scan a massive 500-page corporate merger document in seconds.
Which is incredible in its own.
Definitely. And it flags a tiny loophole in Section 42 that exposes the company to a specific tax liability. It drafts a revision. but the workflow is physically designed so that the revision goes nowhere until a human lawyer reads the flag,
Right, they have to verify the loophole.
verify the loophole, and provide a digital signature to approve the change. It essentially bridges the gap between the speed of an algorithm and the necessary caution of the law.
And that actually brings us right back to the AI trader from CDS we mentioned at the start. That framework where different agents evaluate market signals and debate strategies collaboratively.
Which is fascinating. But if it is simulating market reasoning and not doing live execution, aren't we essentially just building a digital sandbox for algorithms to argue about finance?
We are, but think about the actual value of that sandbox. By having multiple agents debate a strategy, they are rigorously testing the logic of a trade before any real capital is deployed.
Oh, so the consensus itself is the product.
Exactly. Whether it's a legal AI, a scientific AI, or a financial AI, these open source projects prove that the one-size-fits-all model is fading fast. Teams are building highly dependable assistants tailored for extremely specific domains.
Okay, but this raises a massive logistical problem.
How so?
Well, if I have a scientific AI doing lab analysis, a legal AI drafting my contracts, and a team of financial AIs arguing in a sandbox, how do you actually manage all of that? I mean, if you just let all these autonomous agents loose, it sounds less like a streamlined business and more like a chaotic digital zoo.
That is a very fair point.
Right.
Which logically requires an entirely new layer of software. Autonomy without organization is just chaos.
Right.
If you have specialized agents making decisions, you desperately need infrastructure to keep them grounded, accurate, and connected to your actual business processes. And this is the second major pattern we saw: orchestration and grounding.
Because even just figuring out which tools to use is a nightmare. The sources brought up something called Awesome AI Agents, which is essentially a curated discovery hub, right?
Yeah, it basically acts as a directory for multi-agent systems, so teams can actually compare all these different frameworks.
Discovery is step one, but once you select your tools, the immediate challenge is keeping the AI grounded in your specific reality.
Exactly, and that is where a framework like Needle comes in. It's a tool for fast retrieval and context management.
Let me make sure I understand the mechanism here. If I ask a standard AI a question about my company's internal HR policy, it will likely hallucinate an answer because it hasn't read my specific company handbook.
Correct. It lacks context.
So Needle is kind of like a sous chef. If the AI is the master chef who knows how to cook anything but doesn't know what's in my specific kitchen, Needle actively runs to the pantry. My database fetches the exact right ingredients and hands them to the chef right as they start cooking.
That is a highly accurate way to look at retrieval augmented generation, or RG. Needle indexes your data and supplies the relevant context precisely when the model needs it.
Making the output factual rather than fictional.
Precisely. But if you are relying on that sous chef to fetch the right ingredients, you need a way to prove they are actually grabbing the right stuff. That's the exact problem MTB solves.
The benchmark suite for text embedding models. Okay, I have to admit, whenever I see the word embedding, my eyes just completely glaze over.
It's a dense topic.
It sounds like inserting a YouTube video into a blog post, but I know that's not what this is.
No, but it's a very common point of confusion. And embedding is simply how an AI turns text into numbers so it can understand meaning. Think of it like a giant, multi-dimensional map.
Okay, a map.
Yeah. The AI places the word king at specific coordinates. It places the word queen right next to it because they are semantically similar. But it places the word apple miles away.
Okay, so it's plotting concepts on a map based on how closely related they are?
Exactly. And MTB provides the data sets and standardized metrics to evaluate how accurate a specific model's map really is.
So it lets developers compare them.
Right. It allows a developer to scientifically prove Model A is objectively better at mapping and retrieving our specific data than Model B. It replaces all the guesswork with rigorous evaluation.
Okay, so we have the tools, we feed them the right facts with Needle, and we prove the facts are accurate with MTB, but then we actually have to use the output.
Yeah, that's the tricky part.
The sources mentioned a tool called Rflow, which organizes AI-generated outputs into structured workflows. Now, wait a minute. LLMs are basically unpredictable text generators.
They definitely are.
They might answer a question perfectly one day, and the next day start the answer with, sure, I'd be happy to help with that, before giving the actual data.
Yep. The classic chatty AI problem.
If you are trying to feed that output into a rigid database, isn't Rflow basically trying to build a neat picket fence around a chaotic storm?
It is trying to build a fence, yes, and that highlights the biggest growing pain in the industry right now. Getting an AI to write a creative essay is trivial at this point.
Right.
But getting an AI to output perfectly formatted JSON data, That highly specific bracketed text format that a database requires to function every single time without fail, that is incredibly difficult.
Because if the AI adds one conversational sentence at the beginning, the entire database pipeline breaks.
Exactly. Rflow acts as the filter. It refines and structures that chaotic conversational content so your automation pipelines don't just crash when the AI decides to get friendly.
It enforces consistency.
Yes. And speaking of pipelines, we have to look at N8N MCP. N8N is already a powerful automation tool. Think of it as a highly advanced version of Zapier for connecting different software.
And MCP.
MCP stands for the Model Context Protocol.
Which sounds like a lot of jargon, honestly. What is the actual mechanism there?
It's essentially a universal adapter. It is an integration layer that safely connects those NAN automation pipelines directly to language models.
So instead of the AI just giving me a set of instructions on how to update a spreadsheet, this protocol allows the AI to reach out, securely connect to my spreadsheet software, and literally push the buttons itself.
You've got it. When you look at Needle, MTB, Rflow, and N8N MCP together, you realize this isn't just about making language models smarter anymore.
It's about interoperability.
Exactly. If you are a manager or a business owner listening to this, this is why it matters to you. These are the tools that finally allow you to trust the automation you are building.
But, this assumes someone is actually building it. All these orchestration layers and universal adapters don't just manifest out of thin air. Developers have to write the code.
They do.
And if developers are constantly wrangling chaotic AI outputs and building infrastructure, they are going to burn out. Which leads us to the third core theme: how these tools are fundamentally redefining the developer's daily grind.
Because the actual friction of building software is changing. Historically, if a developer wanted to use AI, they had to leave their coding environment, open a web browser, log into a chatbot interface, ask a question, and then copy and paste the answer back into their code.
Which totally breaks their flow state.
Completely. The new wave of open source tools brings the AI directly to where the developer lives.
Like Codra. The sources highlight this as an open source platform for AI-assisted coding, but it's not just a fancy autocomplete that finishes your sentence, right?
No, not at all. It provides interfaces for prompt-driven coding and interacts directly with the code repository. It's truly AI-native development.
It keeps the developer in their environment. And another tool addressing this friction is DeepSeek TUI. TUI stands for Terminal User Interface, if I remember correctly.
That's right.
I found the problem this solves really interesting. The terminal, or the command line, that black box with the green text where developers type raw commands, is basically their home turf.
It is.
DeepSeek TUI is a text-based application that brings DeepSeek's AI models right into that command line. It's entirely keyboard-driven. It's like having an expert consultant sitting directly inside your toolbox, rather than having to walk down the hall to a separate office every time you need advice.
It is all about removing the friction of context switching. And that friction doesn't just happen when writing code. It happens when reviewing it, too. The source brought up a tool called Rue. It's a visual code review and diff inspection tool.
Okay, for anyone listening who doesn't stare at code for a living, a diff is a file that shows the differences between two versions of code, like what was deleted and what was added.
Yeah.
And they are notoriously ugly. It's usually a chaotic wall of red and green text that literally makes your eyes bleed.
Parsing a diff manually is incredibly tedious manual labor. Rue processes those diffs and highlights the modifications in a structured, highly visual format.
So it cleans it up.
Yes, it translates the matrix into something a human can actually read at a glance, massively speeding up team collaboration and pull requests.
And then there is Exuder, a lightweight local utility for chaining commands and automating repetitive tasks on your local machine. Which is kind of funny, actually.
Why is that funny?
Because we just spent 10 minutes talking about massive multi-agent AI frameworks, and then we have Exuder, which is basically just a really good script runner.
Well, but that highlights a really vital point. Not every problem requires a multi-agent neural network.
That's very true.
If a developer just needs to batch rename 500 files or automatically deploy a test server, spinning up an LLM is massive overkill. Exeter provides simple, local automation without all the heavy orchestration.
It's the right tool for the right job. When you look at Codra, DeepSeek TUI, Rue, and Exuder, the narrative is really clear. These tools aren't replacing developers.
Not at all.
They are stripping away the friction. They are removing the manual labor of reading bad diffs or typing out long, repetitive commands so the developer can focus entirely on logic and architecture. They're practically upgrading the human.
They are. But all of this high-level logic, all of these frictionless environments, and all of these hyper-intelligent AI agents share one massive vulnerability. They all require immense amounts of compute power.
Which means the physical servers are running hot. I mean, if the underlying infrastructure crumbles or if the network drops a connection, the smartest AI in the world is effectively just a paperweight.
Exactly. So the final section of our map covers the unsung heroes, the foundational infrastructure, the memory management, and the hardware protocols that prevent this entire house of cards from just collapsing.
The sources started this section with Telegraph by Influx Data. It is a plugin-driven agent that gathers logs, metrics, and events across servers and containers.
Because data ingestion at scale is a massive logistical challenge. When you have thousands of AI agents running simultaneously, you need to know exactly how much CPU and memory they are consuming at any given millisecond.
Wow, yeah.
Telegraph constantly gathers that telemetry data so you have real-time visibility into the health of your systems.
But knowing your server is crashing is only half the battle. You still have to actually fix it, which is where OpenSRB comes into play. SRE stands for Site Reliability Engineering.
Yes. And OpenSRE brings AI assistance directly into the incident response workflow.
How does that work in a crisis?
Well, if a critical database falls over at 2 a.m. on a Sunday, OpenSRE combines your system observability data with operational tooling. The AI can help diagnose the root cause and even assist in automating the mitigation.
Putting a fire out faster.
Exactly. But the infrastructure running these tools isn't always a massive temperature-controlled data center. The sources pointed to K3s, which is a lightweight Kubernetes distribution.
Now, Kubernetes is normally this massive, complex system used to manage containerized applications, right?
It is. It's huge. K3s strips all the heavy overhead out of it so it can run in resource-constrained environments.
So, edge computing.
Precisely. Edge computing means running the software out in the physical world on a small device inside a retail store or on a factory floor rather than in the cloud. K3s lets you run reliable, modern infrastructure on a machine the size of a shoebox.
And if you are running machines out in a retail store or a factory floor, you are dealing with real-world networks, which means terrible Wi-Fi, dropped signals, and latency. That explains the need for Hysteria. It's a proxy and tunneling protocol.
When a network connection is unstable, data packets get lost in transit. Hysteria uses modern transport protocols to push traffic through efficiently.
So it just fights through the latency.
Exactly. It maintains an encrypted, stable connection even when the underlying network is basically falling apart.
It forces the data through the noise. Now, the next tool gets really deep into the weeds. DS4, an open-source C library from Anti-Res. It is optimized for memory usage in native environments. My question is, why does an AI boom suddenly require highly optimized C libraries?
Because AI consumes massive amounts of RAM. Python might be the language developers use to build AI applications, but C is the language of the hardware.
Right.
When you are building the low-level infrastructure to support 1 million AI transactions, you cannot afford to waste a single byte of memory. DS4 provides ultra-compact data structures.
Got it.
It handles the raw memory allocation natively so the system doesn't just buckle under the weight of the compute requirements.
It's like packing a suitcase perfectly so you don't have to pay for an extra checked bag, but at a microscopic digital level.
That's a great way to put it.
And speaking of foundational infrastructure, we have to talk about security. Yellow Key is a utility they highlighted for securely handling credentials and authentication data.
Yeah, if you have autonomous agents executing workflows across different APIs, and developers using local scripts to automate deployments, managing who has the passwords is critical.
The keys to the castle.
Exactly. Yellow Key integrates into sensitive applications to ensure that access logic is completely bulletproof.
Okay, but this next one is my absolute favorite part of the entire source list. We have spent this entire deep dive talking about autonomous AI trading bots. We've talked about multi-agent scientific researchers. We've talked about AI site reliability engineers putting out server fires at 2 a.m.
Yeah, we've covered a lot.
And then at the very end of this hyper-futuristic list, we have an open source project simply called What Cable.
It really grounds the whole conversation there.
It is a literal hardware identification utility. It is designed for technicians to look up hardware standards so they can figure out what physical plastic wire they are currently holding in their hand. I mean, it is hilarious, but it is also profoundly true.
It is the ultimate reality check. As software becomes increasingly abstracted, moving from code to multi-agent reasoning loops, we forget that the physical world is still the foundation.
Right.
The demand for physical hardware references, secure credential management like Yellow Key, and low-level byte optimization like DS4 becomes the most critical piece of the puzzle. Eventually, someone still has to physically plug the machine into the wall.
So if you are listening to this on your commute or at your desk, what does this map actually mean for you? We have covered a massive amount of ground today.
We really
We
have.
started with the hyper-specialized AI agents doing the heavy lifting in law and science. We looked at the critical orchestration layers like Needle and Rflow that act as the sous chefs and filters to keep those models grounded in your company's actual data.
Yep.
We explored how tools like Codra and Rue are systematically removing the friction from a developer's daily life. And finally, we dug into the bedrock, the telemetry, the memory optimization, and the literal cables required to prevent the whole thing from catching fire.
It's a full stack.
It is. Whether you are a developer writing the pipelines, a manager trying to figure out which AI to trust, or just someone who is insanely curious about where the tech landscape is heading, understanding how these layers connect gives you a massive advantage. You aren't just drowning in GitHub repositories anymore, you understand the architecture.
And as you look at that architecture, I want to leave you with one final thought to mull over.
Okay, let's hear it.
We've seen tools like Hermes that autonomously execute complex workflows. We've seen Codra natively writing and interacting with code. And we've seen platforms like OpenSRE automating system reliability and incident response.
Right.
If you connect all of these layers to the bigger picture, you have to ask what happens when the underlying infrastructure tools start independently managing and repairing the AI agents that are, in turn, writing the code for our next generation systems.
Oh, wow.
When the entire stack becomes self-generating and self-healing, where exactly does the human fit into the loop?
Wow, that is like heavy, fascinating comment to leave on. From feeling like you were drowning in a flood of repositories to realizing the water might just start navigating itself. Thank you so much for joining us on this deep dive. Keep questioning, keep learning, and we will catch you on the next one.